Rituparna Bora, Assistant Professor, Pandu College, Guwahati, Assam. And today my presentation is based on the topic buffer. Actually, buffers are compounds or mixtures of compounds that by their presence in solution resist changes in the pH upon the addition of small quantities of acid or alkali. That means if you add acid or alkali in small amounts, the buffer solutions, the pH does not change. It resists the changes in pH. Now, what is the necessity of a buffer system? Actually, sometimes it is necessary that a solution of definite pH be prepared and stored. The preservation of such a solution is even more difficult than its preparation. Mainly, actually in pharmaceutical solution, the pH should be properly maintained. But it becomes very difficult because if solution comes in contact with air, it will absorb carbon dioxide and becomes acidic. On the other hand, if solution is stored in a glass bottle, alkaline impurities from the glass may alter its pH. Due to these reasons, pharmaceutical solutions are buffered as the buffer solutions are capable of maintaining pH at some fairly constant values when even small amounts of acid or bases are added. Now, what are the types of buffer? Actually, buffers are two types, acidic buffers and basic buffers. Now, acidic buffers. An acidic buffer is a combination of weak acid and its salt with a strong base. For example, we can take acetic acid and its sodium salt. Acetic acid is a weak acid and its sodium salt is a salt with its strong base sodium hydroxide. So this acetic acid and sodium acetate can be taken to prepare a buffer solution. Similarly, there are several examples. These are given here. Actually, basic buffers is a combination of weak base and its salt with strong acid. For example, you can take ammonium hydroxide and an ammonium chloride, mixture of ammonium hydroxide and ammonium chloride. Now there is one more type, that is phosphate buffers. Phosphate buffers are double salt buffers. Actually, there are two types of salt. Two salts are mixed here. One is monobasic potassium phosphate and the other is dibasic potassium phosphate. This is a mixture of these two compounds. Now, what is buffer action? Actually, the resistance of a buffer solution to a change in pH is known as buffer action. Now we have to understand the mechanism of action of acidic buffers. Let us take the example of acetic acid and its sodium salt, sodium acetate. Now here the equation is given. The acetic acid is decomposed to give sodium plus ion and acetate ion. Then if we add HCl, this is a strong acid, to a solution of acetic acid, to a mixer solution of acetic acid and sodium acetate, then what will happen? The H plus ion from the hydrochloric acid will combine with the acetate ion of sodium acetate to produce acetic acid again. Now this acetic acid is a weak acid, so it is not strongly ionized. That's why the pH is slightly affected or not affected. The hydrogen ions yielded by the HCl are quickly removed as unionized acetic acid, and the hydrogen ion concentration is therefore only slightly affected, because acetic acid produces very weak as compared to HCl added. Now, if we add a strong base, then what will happen? Suppose we are adding sodium hydroxide. It will decompose to give sodium plus and hydroxyl ion. Now, this hydroxyl ion will combine with the hydrogen plus ion, H plus ion, to give H2O. Then again the buffer is, the pH of the buffer is not changed that much, because the hydroxyl ion is removed by forming H2O. That's why when we add strong acid or strong base, the pH of the buffer is not, acidic buffer is not changed, or it is slightly changed. The mechanism of action of basic buffers. We are taking ammonium hydroxide and mixture of ammonium hydroxide and its salt ammonium chloride. Now, to this mixture, if we add hydrochloric acid, then again the hydrogen ion from HCl will combine with the hydroxyl ion to produce H2O, and again the pH is not changed. And when a base is added, ammonium hydroxide will be produced, and the pH remains constant. Now, here is given the mechanism of action of phosphate buffers. Here, from these equations also we can understand the pH is not changed by addition of acid or base. Now, this is a short lesson about buffers. In the next presentations, I am going to share a broad, I'm going to speak broadly about buffers. Thank you.